Hello, welcome to this new video. In this video, we are continuing simple microscope and we are doing the part 2 under that heading. We have derived an expression for angular magnification of simple microscope when the image is at least distance of distinct vision. In this video, we are going to derive an expression for angular magnification of simple microscope when the image is at infinity. Before we pass on to angular magnification for compound microscope, we will finish this video and then pass on to angular magnification for compound microscope. But before we start with the video, please watch the video completely, and if you think the video is useful, like the video, share the video with your friends, and also leave your comments in the comment box if you have any comments. And please do not forget to subscribe to my channel and also press the bell button so that you get intimated as soon as videos are posted. Thank you very much. I have given here two ray diagrams. Let us mark them as 1 and 2. Diagram 1 is the ray diagram for image formed at least distance of distinct vision. We have used this diagram in the previous video for deriving an expression for angular magnification when the image is formed at least distance of distinct vision, marked as D. If you have not watched that video, please click the I button on the right hand top corner of the video. You can watch that video. In this video, we will be using the diagram marked 2. That is, the image is at infinity. Here, the object is at focus. In the previous case, the object is between F and C. A ray passing from A strike the lens and get refracted and pass through the focus on the other side. Another ray passing through the optic center passes on without deviation. When these two rays are extended backward, they will meet at a very distant point, that is at infinity, where the image will be formed. Negative V will be equal to infinity. Here, negative V is equal to D. We have to derive an expression for angular magnification M when the image formed is at infinity. The image is at infinity, so the object has to be at focus, and this distance will be focal length. That is, the distance of the object from the lens will be the focal length. In order to calculate angular magnification, we need to know tan alpha and tan beta, that is the angle subtended by the object and the image at the eye. For clear vision, the object has to be at least distance of distinct vision D, that is without the lens. Then tan alpha will be equal to height of the object divided by D, that is the object has to be at D. So tan alpha becomes H by D. What about tan beta? That is the angle subtended by image. Image is at infinity. This diagram I have shown only to represent image formation at infinity. These are the two rays that are extended backwards, and these rays will meet only at a great distance backward. And I have shown here gaps in order to represent that. A dash, B dash is the image. We do not know the size. And what is the distance between C and B dash, that also we are not quite sure. Tan beta we can write as H dash divided by negative V. But these two quantities are difficult to be obtained. So we equate these two triangles A dash C B dash and A C B, and derive an expression H dash by negative V is equal to H by negative U. But in this case, negative U is equal to F. So what happens? Tan beta becomes equal to H by F. So we have an expression for tan alpha and tan beta. From this we can easily find out the angular magnification M, that is equal to tan beta by tan alpha, and that will be equal to H by F divided by h by d. That will be h by f multiplied by d by h. So these two quantities get cancelled and what remains is d by f. Angular magnification for simple microscope for image at infinity will be equal to m is equal to d by f. You can compare this with the expression that we obtained when the image was at least distance of distinct vision. M is equal to 1 plus d by f. So in this case we find that the magnification is 1 less than the magnification for image at least distance of distinct vision. Though the magnification is less in this case, this will be more comfortable for the observer because the eyes will be more relaxed when the image is at infinity. And moreover, the difference in the magnification will not be very great. I hope you understood this. So, in case of simple microscope, we have to consider angular magnification for two different cases. That is, image at least distance of distinct vision and image at infinity. I hope these 2 points are clear. We will meet in the next video with the next topic. Thank you.